Let's look at a simple example of synchronization. And we're going to look at two different ways of synchronizing something. Now, we're going to go and we're going to modify our simple runnable slightly. And as we see here on line 22, we're going to add a counter class. Now, let's then first look at this counter class at the bottom here. What we're doing is we're creating a counter. We're going to start the counter at 0, and we're going to add two methods. We're going to have an add method on line 61, and this method specifically is synchronizing the access to the add, which does not return anything, but it increments by some value. And we're going to modify the count by adding count and value together. Now, notice that the count here on line 59, it's not synchronized or anything, it's shared data in this counter. Now, additionally, we're going to have a get method, which actually synchronizes the getting of this count. So, the thing to point out here is that on line 61 and on line 65, either adding or getting individually is synchronized. Only one thread at a time can add or get, but that does not mean that they are synchronized together, both of the methods together. Now, let's go back up to our runnable and let's try to add this specifically here. Now, what we're going to do is our simple runnable has a counter, but it's a shared counter. And we're going to modify our simple runnable to actually take a counter, as we see here. So we're going to create an instance of one counter, and we're going to give it to each and every runnable, which is two runnables for us. So now looking at the constructor real quick, all we're doing is we are taking the counter that we're given and we're adding that counter. Now remember, this is a shared counter between both of the runnables. There's only one instance of the counter, even though they are synchronized. Now, when we're actually looking at running this, here's what's happening. We're going to go into our run method, and we're actually going to get this. We're actually going to do counter.add. Now remember, multiple threads can be executing the add, or at least trying to. Only one's going to add at a time. However, look at what we do with the next line. We're going to do counter.get. So one thread could be out adding while another thread is getting that value. They themselves are not synchronized between the two different methods, but the add can guarantee that only one thread is adding at a time, and the get can guarantee only one thread is getting at a time. Now that's standard synchronization on a method. Now we can actually go a step further with this. We could actually decide to say, you know what, we want to group these operations together, and we can do a synchronized block. Right? So if we do a synchronized, and we need to synchronize on something, so let's just say I'm synchronizing on this, or me, and what we can do now is we can decide to synchronize both of these operations. Now what happens is only one thread at a time can get into a synchronized block. Now that's going to ensure that only one thread at a time will go into the count, and the same thread, because it's in this block, will only get into the get. And now both these operations will now only happen by one thread at a time until we release the lock at the end of the synchronized block.